Welcome to Hartman Math. This is lesson 4.2, radical expressions and rational exponents. Begin with a little bit of review where we list the first 10 perfect squares. They must be squares. It should look like 1 squared, 2 squared, 3 squared, 4 to the second power, 5 to the second power, 6 to the second power, etc. Now, the first 7 perfect cubes. 1 cube, 2 cube, 3 cube, 4 to the third power, 5 to the third power, 6 to the third power, 7 to the third power. We're going to wrap up with the first 5 perfect quartics. You might not be familiar with that word, but you can kind of sense the pattern that we're going through, so I bet you could do it. 1 to the 4th power, 2 to the 4th power, 3 to the 4th power, 4 to the 4th power, 5 to the 4th power. These are going to help us with our radical expressions, which are roots, taking square roots, maybe cube roots, maybe 4th roots, and so on. So we'll begin with square roots. These should be pretty simple. Go ahead and evaluate the square root of 1, the square root of 4, the square root of 9. Shouldn't need calculator for this. 1, square root of 4 is 2, 3, 4, square root of 25 is 5. Now here, a little bit different notation. There's a number in the notch of the root sign. That's called an index. And it's just the same as it was up here. There's an invisible 2 on here because we're taking a square root. And a square root means a second root. So this still means the same thing as just square root 36 is 6. Square root 49 is 7, 8, 9, 10. Therefore, what are inverses of squares? What did we just do? We took square roots. Square roots are the inverses of squares. When we took the square root of 49, we got 7. 7 squared is 49. That's the relationship. So this time we see there's a 3 in the notch. That's the index, saying third root of 1. What is the cube root of 1? Basically asking, what number would you cube to get an answer of 1? And the answer is 1. What would you cube to get 8? 2. What would you cube to get 27? 3. Because 3 to the third power is 27. 4, 5, 6, and 7. So, what would be the inverse of cubes? Cube root. So let's simplify some radicals. We've already done this with square roots, so this should be a review. Remember our product property for square roots, that the square root of a product can be broken up and split up into the square root of its factors. And we would like the first factor to be a perfect square. So think about how you might break up the square root of 20. Square root what times square root what? The first one needs to be a perfect square. Go back to your list of perfect squares. I think we want 4 times 5. Square root of 4 times square root of 5. That makes square root of 20. Square root of 4 is 2. Final answer, 2 times the square root of 5. About for 63. Square root of 63, we want to break that up. We're looking for a perfect square that evenly divides into 63. We're looking for 9. Square root of 9 times square root of 7. And the square root of 9 is 3. Make sure we write 3. We don't write root 3. It's just 3. Square root of 9 is 3. When you say 3, you just write 3. 3 root 7. This one has a negative on the outside, but that's no big deal. We'll just leave it there. Break up the square root 700. What perfect square goes into 700? 100 does. Square root negative, square root 100, square root 7. This is just 10. So negative 10 times the square root of 7. This one's got a number on the outside. No big deal. Just like this one had a negative on the outside. No big deal. Focus on the inside. Focus on the 50. What perfect square goes into 50? 25. So keep the 4. Square root 25 times square root 2. This becomes 5. And this is implying multiplication. So 4 times 5 times the square root of 2. 4 times 5 is 20. 20 square root 2, or 20 times the square root of 2 is our answer. All right, a few more radicals, this time cube roots, fourth roots. Same rule applies to both those. It applies to all the roots. We can split up cube roots into cube root times cube root and fourth root for the fourth roots. So when we look for the cube root of 16, it's nice that the square root of 16 is 4, but we're not doing square roots. We're looking for, in your list of cubes, that blue list, maybe, what goes into 16? And it's 8. So we split that up into cube root 8 times the cube root of 2. What is the cube root of 8, being that that's a perfect cube? We already said that that was 2. So it's 2 cube root 2. Very careful with how you write this. We're going to need to make sure that your cube root, that index of 3, stays in the notch of the radical. Don't let it drift out in front where we think it's now going to become an exponent. It's not. 2 times the cube root of 2. All right, cube root 500. What cube root goes into 500? We could try this on a calculator as far as does 8, that's on our list, go into 500? It does not. I don't think we need to bother with 27. Well, we could try it. Does 27 go into 500? No. What about 64? No. What about 125? Yes. 125 does go in. It's 125 times 4. So cube root 125 times the cube root of 4. This is 5. So 5 times the, whoops, that should be a 3, cube root of 4. Cube root of 4. All right, now we're looking at fourth roots, so we need to drop down to that list of those quartics. What goes into 112? One doesn't really help, so the next one in the list is 16. Does 16 go into 112? Yes, it does. 116 times 7. The fourth root of 16, not saying the square root, the fourth root of 16. What number to the fourth power is 16? That's 2. So our final answer is 2 times the fourth root of 7. We got a number on the outside. No biggie, we'll leave that there. What about the fourth root of 405? Does 16 go into 405? No chance. It's an odd number, so it can't be even. What about 81? That's the next number in our list. It does. 81 times 5. Fourth root of 81 is 3. 4 times 3 times the fourth root of 5. 4 times 3 is 12. 12 times the fourth root of 5. So that's some practice with radicals. So now the last thing we're going to look at is just rewriting between radical form and rational exponent form, which means just the exponent is a fraction. So here's the way that it works. If we're talking about integers p and q, q's got to be greater than 0, a can't be 0. So we're raising a variable, a number, to a power that's a fraction. Rewrites into radical form. Roots mean radicals. Radical form. The denominator becomes the index. That's the one you got to focus on. The denominator becomes the index. The numerator is the power. power could be inside here, outside, it doesn't really matter. But more importantly, the index is the denominator. So our problem here just says rewrite. That's it. You don't have to simplify. You don't have to solve. You don't have to do anything, but just rewrite from radical form into rational exponents. So here's our base A raised to the power of what over what. The index is always the denominator. So that means that the 3 has to be the numerator. 11 to the power of 3 over 7. Make sure your exponent looks like an exponent. It needs to be high and small. If you write 11 and 3/7, I'm going to think it's a mixed number. So make sure we write the exponent clearly. Low, small, and high. 11 to the power of 3/7. X to the power of denominator, numerator. So it doesn't matter if that's inside or outside. So x to the power of 5 on the bottom, 2 on the top, 2/5. This one's a little bit different. It doesn't have the power, or the power. What is our exponent? So 1. So this is 14 to the power of denominator, numerator. 14 to the power of 1/4. Make sure your exponent looks like an exponent. What if we reverse these? We start out with this. Can we go back to this? Probably should say rewrite each expression using radical expressions, not exponents there. So we got 8 to the power of 1/3. We're going to rewrite it as a root. The denominator is the index. 3rd root of 8 to the first power. We don't need to write to the first power. All right. In the denominator is the index. The 2nd root, or maybe just say square root of y to the 9th power. And because it's square root, we don't have to write the index. We can put a 2, but it means the same without writing it. It's an invisible 2. What about this one? The denominator is the index. 8th root of 10 to the 3rd power. You can put the exponent on the outside as well, use parentheses, any of that works. But that's it for today. I'll see you next time.